Hi guys, in today's video I'm going to be programming this Raspberry Pi Pico to play a tune with this speaker here. Now of course you don't have to use a Raspberry Pi Pico, you could use another microcontroller that uses MicroPython and CircuitPython. This project went really well and the tune sounded better than I thought, so I kind of carried on and made a little instrument. Obviously this instrument doesn't look the best, it's a prototype, so I used some Sharpies, I also used these stickers here, so you can see it does look a bit like a dog's dinner, but you can hear it does work. In my next video you're going to see me manufacture that keyboard and write a little bit of code to program it to work. But in today's video, we're just playing a tune on a microcontroller, in my case a Raspberry Pi Pico. Now you could pick one of these up for about £4, but of course, like I said, you don't have to use a Raspberry Pi Pico, you could use any microcontroller that uses CircuitPython or MicroPython. And you could pick up one of these speakers for about under £1. You'll also need a resistor. I'm going to be programming in MicroPython, but I'll show you how to do it in CircuitPython as well. We'll cover dictionaries and use PWM, and you might pick up some useful tips along the way. Really quickly, this is my circuit. So this is my Raspberry Pi Pico. It doesn't have to be a Raspberry Pi Pico, you could use something else. Down here is my GPIO pin of choice. You can use any you want as long as it's a PWM pin. Pulse width modulation. In a video we've done, my sister explains about PWM on a whiteboard if you want to know more about that, so link should be in the description. So it goes along through a resistor, then up to the speaker, and then the other leg just goes all the way down to ground. Simple. I'm going to be using MicroPython, but you can use CircuitPython if you want. So I'm going to start off by importing the things I need. So I need to get machine, and I also need to import time. Okay. Now, if you're using CircuitPython, you need to import time, board, and PWM-IO. Okay. Now I'm going to set the pin to a PWM pin. So I'm going to speaker equals machine.pwm, all capitals. And then I need to tell it what pin I'm setting to a PWM pin. So I need to go machine.pin with a capital P. Then the pin number, which I have chosen 2. Now I need to set the duty cycle, so I'll go speaker dot duty underscore U16. The duty cycle has to be an integer, so I'll put int there, but I want it to be half of 65535, so I'll go divide by 2. If you're not using a Raspberry Pi Pico and this number doesn't work, then I recommend halving it. And then if that doesn't work, halving it again. If that doesn't work, halving it again, and so on. Now I think it's time to make the speaker sound. I'm going to go speaker, which is a variable we've made up here, dot frec, which I think stands for frequency. Then in here, we put an integer. It has to be an integer of a frequency. So I'm going to do middle C. So here's middle C, C4. Now, if you don't know what I'm talking about, C4, C is just the note name, and the number 4 is how high it is. So you can have C4 and C5. C5 would be higher than C4. You can also have D4, which would be a little bit higher than C4. C4, which is middle C, is 261.6 Hertz. If we round that to 262, because it only takes integers, so we go 262. And then we want it to go on, let's go for 3 seconds. And then finally, let's turn the duty cycle off, so therefore it won't sound. 0. Let me go and run that. This is a video of me pressing the C on the piano. And I'll run the program as soon as I go and press the C to see how different they are. To be honest, the speaker's probably more accurate than our piano. I'm going to make it go C, D, and E. So here, this is C here. So I'll copy that, paste it here, And then instead of 262, I want D. So if I go to the piano frequencies, D4 here. So that's 293.6. So let's run that to 294. Now we need that to go on for 3 seconds, let's say. 3. And then we'll paste it again here. And then we need an E, so an E4, let's look for that. E4, that is 329.6, so let's go 330. Okay, then we want that to go for 3 seconds. And then the duty cycle turns off. I'm just going to quickly change these two all to 1. And that's pretty cool. I think it's taking a bit too long to go speaker.frequency and then go to the internet, find the note name that I want, look for the frequency, and go write it in, and go time.sleep, and then do it all over again. So I think it's time to add in a dictionary up here. I'm going to call my dictionary note frec, and then equals, in dictionaries you have these curly brackets, and then a dictionary is just a list of keys and values. So I'm going to put the key in, which is, let's just do the ones I've got here. So first of all we had C, didn't we? So that's C4, then colon, so that's the key, and then we put in the value, which is 262. Okay, so now I'll do the other one, so I think we had D4 here, and then finally we had E4, which is 330. Okay, and then to finish off our dictionary, we go and put the closing curly bracket there. So now we can swap these by going note underscore frec, then the square brackets, and then C4. Oh. I think now it's time to add in a function where we give the function the note name as a string, and then it will play that note we've given it for how long we've said. So I think up here, def, because that's how you make a function. Then I'm going to call it play note, because that is what it's going to do. Then in the brackets we need to tell it what we're giving it. So we're going to give it the note name and the duration. Okay, cool. Oh, I forgot my colon. There we go. So what do we do? So first things first, we're going to give it a string, aren't we? So we need to go into the library and then define that string and then see what the value is and put that into a variable. So I'm just going to explain to you what I mean by dictionary. You may hear me call them libraries, but I'm just meaning my note library. You can see my dictionary is called note frec. If I just type into REPL note underscore frec, you can see it just shows me everything inside note frec. So for example, if I just go note frec, then in the square brackets, I just put, let's just choose something. Let's go E4, which is 330. It shows me 330. It's pretty simple. So I'm going to call that variable frequency. And then we go note frec, which is the library up here. Then we put these square brackets, and then in the square brackets we put note underscore name, because that is what we're inputting. So now it's actually quite simple. So all we go is speaker dot frec, and then in the brackets all we have to put is frequency. Now we just need to do the time, so the duration, time.sleep, then just duration. And then we need to turn the duty cycle off. So I'll just go and copy this. And I'll paste it here and then get rid of this. And turn that into 0. So now that's our function done. So I think we can delete all this. Now let's have a go at calling our function. So all we have to do is play note, then C4, And then let's go 1 second. And I'll just copy this. Okay. Then we go D4 here. E4. If what I've done is correct, then it should just play what it was playing before. But obviously this code looks a lot more simpler now. So let's run it. I know why it didn't work. It's because we need to turn our duty cycle back on after everything. Top of the function here, I'm just going to turn the duty cycle on. So we don't really need this line anymore, do we? So I'll get rid of that. Oh wait, I forgot to, it needs to be tabbed. It worked, great. The speaker wasn't very loud, so I went in and added a chip. So this is the LM386 chip, and my sister's done a video about this, so go check that out, link should be in the description. You can get 5 for £3 off Amazon, which is really good value, but I have seen them really cheap in other places. If I run the program without the chip, it's very quiet, I can barely hear it. And then with the chip in, when I run it, it's way, way louder. Of course, this circuit did work perfectly fine before we added the chip, but it just wasn't loud enough for me, so I added in the chip. I added in a stronger resistor. This is a 1K resistor rather than the 330 resistor we were using before. You don't even have to get one of these chips. For example, you could get one of these, which is also dead cheap. In fact, I got a massive bag full of them, really cheap. This is probably better to use since it's got all the components on. There's the chip. But I do like to use just the chip by itself since I can put it on the breadboard and physically see it and mess around with it. Now, I did say you didn't have to use a Raspberry Pi Pico for this. You could use something else. So I'll tell you what I'll do. I'll use a tiny 2040 with, instead of this chip, the chip with all the accessories, so this, and I'll code it in CircuitPython instead of MicroPython. Remember, don't let a language restrict you. You can also code it in C or any language you'd like, really. So I'll catch you when I've done that. I've finished that now. Here's the code. I've just gone into VS Code because I don't know how to split screen using Phonic. But you can see on the right is the CircuitPython program and on the left is the MicroPython program. It's really the same logic between them. You can see here we're just importing time and machine, and in the CircuitPython one we're importing time and then board and PWM-IO instead of machine. Line 10 in CircuitPython we're setting pin 2 as a PWM pin as well. You can see here we've got .gp2 instead of .pin and then in brackets 2, but they're doing the same thing. And then in the same line we're setting the frequency. We're also setting the duty cycle. Finally here, I didn't have this before and I couldn't change the frequency and the error note wasn't very helpful. We need this boolean here to be able to change the frequency in CircuitPython. You can see in MicroPython we have got the method and we're passing it an integer. Whereas in CircuitPython we are setting a property. With the duty cycle that's the same. Whoops, looks like there's a space between the dot and duty. I'll get rid of that before I run it or it won't work. That's about it, and as I say, they are the same logic. With the Pimeroni Tiny 2040 and the CircuitPython code, when we run it, you can see it works. And then with the Raspberry Pi Pico and the MicroPython code, when we run it, that works as well. Now we've got our function. Instead of just putting play note, then the note name, then how long we want it to go for in the order of the song, I need a list. Inside this list is going to be little lists, and inside those little lists is going to be the name and duration. But before I can do that, I need to put these notes into my dictionary. My sister's given me a list of the note names and frequencies, so I'll just quickly do that. Okay, I've done that, so now I can make my list. I think I'm going to call my list tune. Now I'm going to call it theme. And we use square brackets because it's a list. And inside those lists is going to be some other square brackets. Inside this mini list is going to be the note name and the note value. Now this is the order of our theme tune that my sister composed. She gave me a piece of paper with the note names on in order of the song, so I'll write them down. I don't want to waste your time, so I'll just quickly fill in the values, so I'll catch you when I've done that. Okay, I've done that. Let me just explain this list. As you can see, it's a list of smaller lists. So I'm just going to copy this into REPL. Now to view one of these values, I go theme, and then square brackets because it's a list, and then the numbered value I want to view. So let's say I want to view the first one. List start at 0, so I put theme 0, and it should print out D5, 0.5. It did! Let's do the second one. That would be theme 1. So that's just a brief explanation of my list. So I'm going to get rid of these, and then I'm going to do my for loop. So I go for note in theme. What do we do? Well, it's quite simple actually. All we need to do is call the function play note. The first thing we're calling play note with is the note name, which is a string. So what we go is we go note 1. I mean 0, because it goes 0, 1. It starts at 0. We're also passing it an integer, which is the second part of note. So we go note and then 1, because remember it starts at 0. What this will do is it will go through theme, and the first time it goes through, this will be note. So it will go play note D5 then 1. Then the second time it'll do this, third time it'll do this, and you see it'll just play our song, our theme tune more like. So if I run it, right, well that seems a bit slow, so I'm going to change these ones to 0.5, so I'll catch you when I've done that. Okay, I've just finished that now, so let's run it again, see if it is better. Cool! That sounded like our theme tune, but there's a problem. It seems to be there needs to be rests here and here. So let me fix that. And I'm just thinking how I can do this, because you can't set the frequency to 0. So just for now, so then I know I'm putting the rests, I'll do this. So I'm just going to add in the rest into this list. So you can see I've put the rest here and here. Now most of you will know what I mean by rest. Basically what it is it's just a pause in the music. And I've done that for 0.5 seconds. I also need to add rest to the dictionary up here, so I'll do that now. I'll do R because that's what I've called it down here in the list. So then we'll do the colon. Now I can't set it to 0 because that wouldn't work, because it'll be too small. So I think I'm going to go 100, but it doesn't really matter what I set it to. I need to set it to a legal frequency, because I can't have it too small, it wouldn't work. Okay. What I'm thinking is in this function, I could go do an if statement and say, if note name is R, then turn the duty cycle off. So I'll try that. 16 turns off. And then else, we just turn it on. So I'll just copy this. Actually, so I'll copy that. I don't think we need this line anymore. Okay, let's test that out. It works great. I don't want this video to get too long, so I'll wrap it up there, but in my next video, I'll make that dictionary a function that will calculate any frequency of any note. I'll also make the keyboard using just one GPIO pin.
If you did like this video, please give it a big thumbs up and subscribe if you haven't already.
Also, don't forget to check out my next video where I make my instrument. Have a good day. Bye.